We now finish the field life cycle section and move into more practical drilling topics. Up to this point, we have looked at why wells are drilled at different stages. Now we will focus more on how drilling operations are organized in practice. This slide introduces drilling contracts, which are crucial in real field operations. Two common types are shown here. In a dayrate contract, the operator pays a daily cost for the rig and crew, while many other specialized services remain separate. In a turnkey contract, the contractor is paid a fixed price to design and drill the well according to agreed objectives. This is an important business topic because contract type affects cost control, risk sharing, operational flexibility, and project management. Drilling operations involve many specialized people. The slide lists the rig manager or toolpusher, driller, assistant driller, derrickman, motor hand, floor hands or roughnecks, mud engineer, safety officer, and geologist or mud logger. Each role has a specific responsibility, from supervising operations to handling mud systems, engines, well site safety, and geological monitoring. This slide also reminds us that these jobs are high-paying but high-risk, which reflects how demanding and hazardous drilling operations can be. This slide introduces the major categories of drilling rigs. These include cable tool rigs, rotary rigs, and offshore drilling rigs such as jackup rigs, semi-submersibles, drill ships, and fixed production platforms. This classification is very important because different environments and objectives require different rig types. A shallow land well does not need the same system as an offshore deepwater exploration well. The cable tool rig is one of the earliest historical drilling technologies. It was used in the 19th century, especially in the United States, to drill relatively shallow hydrocarbon wells. Instead of a modern rotary drilling system, it relied on repeated up and down mechanical motion to break rock. This slide is useful because it shows how drilling technology evolved over time from relatively simple mechanical systems to the highly advanced rotary systems we use today. The conventional rotary rig became the dominant drilling rig during much of the 20th century. It includes major components such as the mud pit, shale shaker, mud pumps, drawworks, crown block, traveling block, drill pipe, BOP stack, drill bit, and conductor casing. In a rotary rig, the drill string is rotated to turn the bit and cut the formation. This slide is important because many of the major rig systems introduced here remain fundamental in modern drilling, even if specific equipment has evolved. The top drive rig is a more modern version of the rotary drilling rig. Instead of relying on a Kelly and rotary table to rotate the drill string, the top drive rotates the string directly from the top. This gives greater efficiency, better control, and often safer pipe handling. The slide shows components such as the top drive, mast, mud system, choke manifold, pipe racks, and accumulator. In practice, Top drive rigs are widely used today because they improve drilling performance and operational flexibility. A jackup rig is an offshore rig with retractable legs. It is floated or towed to location, the legs are lowered to the seabed, and then the hull is jacked up above the water level. This makes it stable for drilling in relatively shallow offshore environments. According to the slide, jackup rigs are suitable for water depths up to about 400 feet and can still drill very deep wells once in place. This makes them very useful for offshore exploration, appraisal, and development in shallow water settings. This quiz asks what is special about a jackup rig. A. It can drill in ultra-deep water. B. It can store high amount of oil. C. The top side can be moved up and down on the legs. D. It can be used on land as well as water. Which one you select? The correct answer is C. The top side can be moved up and down on the legs. That is exactly what distinguishes the jackup. The hull is elevated above the sea surface once the legs are secured on the seabed. This design allows the rig to avoid wave action while still operating in offshore conditions. A semi-submersible rig is used in water depths that are too deep for jackup rigs. Unlike a jackup, a semi-sub does not rest on the seabed while drilling. Instead, it floats in a stable semi-submerged condition and is kept in position using mooring systems and often dynamic positioning or thrusters. This makes it suitable for deeper offshore drilling while maintaining stability in challenging marine environments. This quiz asks how a semi-submersible is positioned. A cement structure to the bottom of the seabed. B. Rig positioned with thrusters beneath the hull to keep it in position and moored up. C. Connected to platform. What is the best answer? The correct answer is B. The rig is positioned using thrusters beneath the hull and mooring systems. This is a useful concept because MY students often confuse semi-submersibles with fixed structures. In reality, they are floating drilling units designed to maintain position in deep water. A drill ship is a ship specially modified for deepwater or ultra-deepwater drilling. Its most distinctive feature is the moon pool, which is an opening through the center of the ship that allows the drill string to pass through the hull into the sea and down to the seabed. Drill ships are highly mobile because they can move under their own power from one location to another. This makes them especially valuable for remote or frontier offshore exploration. This quiz asks which rig is the best choice for ultra-deepwater drilling. A platform. B. A jackup. C. Drill ship. D. Semi-submersible. Can you select the best one? The correct answer is the drill ship. This is because drill ships are specifically designed for deep and ultra-deep water, with strong mobility and dynamic positioning capability. This slide reinforces the idea that the environment strongly controls rig selection. This slide introduces fixed production platforms, which are offshore structures installed permanently or semi-permanently at a location. Unlike mobile drilling units, fixed platforms are connected to production infrastructure and are mainly used for development and production operations in established fields. They are very important in offshore field development because they support repeated drilling, production, and intervention activities from one stable location.